A zero of a polynomial function is a number k such that that number k, when plugged into a function, equals 0. Now, if you have a graph, you can easily tell what the zeros are because the zeros are also known as the x-intercepts or the roots of a graph. So the graph that you see below has x-intercepts at -2 and 2. Again, it is the point where it touches or crosses the x-axis. So if we were to plot those, let's plot the point to the left that we would go over -2. So your x value is -2. You're not going up or down, so your y value is 0. So f of -2 equals 0. The same as if you plot the point to the right. You go over 2, that's your x value. You didn't go up or down, so your y value is 0. So f of 2 equals 0. Now, the remainder theorem is a short way to find the zeros of a function when you're not given a graph. So all you have to do is simply use the synthetic division, and if the remainder is 0, then that means that that number that you plugged in, k, whatever it is that you plugged in, that it is a 0 of that function. Here we're going to decide whether the given number k is a 0 of the function. So we want to know whether or not 1 is or not a 0 of this polynomial function. So to do that, we could either use the plug-in method or we can use synthetic division. I'd like to show you the synthetic division method. So our k, which is our 1 here, is going to be on the outside as our divisor. We check to make sure we're not missing any degrees, degree 3, degree 2, degree 1, and your constant, so we're good. So that means underneath we'll have a 1, a -4, a 9, and a -6. Let's begin the process by bring down a 1, multiply that with 1 to get 1. Bring down -3, multiply that with 1 to get -3. Bring down 6, multiply that with 1 to get 6. Bring down 0, and the fact that we have an output, a remainder of 0, f of 1 equals 0, which means that the number 1, it is a 0 of the given polynomial function.